Hi guys, I'm going over BPW 4.1 and I decided that I first wanted to do a quick review about other transformations that we've learned. Okay, so let's start with going over reflection over the x-axis. Each time we had a rule, so starting with the original xy, what's going to happen. Now, I have my handy dandy little board graph paper right here. So imagine if I have an original point of 4 comma 2. If I were to reflect this over the x-axis, it's going to actually flip over to the downside. So this is going to become still 4, but the 2 is going to now become a negative 2. On the other hand, if I had something like 2 comma negative 4 to begin with, then this is going to flip up to become 2 comma 4. So if you compare this and you compare here to here and here to here, the y value changes the sign, but the x value stays exactly what it is. So the rule that we learned was the x comma y, the x value stays, and the y value becomes its opposite. It doesn't mean negative, it means the opposite of it. So if it was a negative sign, it's going to become a positive. Okay. On the other hand, reflecting over the y-axis, say that I have that same point 4 comma 2 to begin with. If I reflect it over the y-axis, now it's going to flip over to the left-hand side, so it's going to come over here. So instead of a positive 4, now you're going to go left 4, so it's going to become a negative 4 comma 2. Now, if you compare these coordinate points, the y values stay the same, but the x value becomes its opposite. So for the same exact reason, going back to the rule, this is going to be, the y value stays the same, but the x value is going to become its opposite, and that's why it's going to become negative x comma y. Okay. Rotation about the origin. So, and I'm rotating it from the center 180 degrees, so it's going to end up down here. Okay. So if it's going to end up down here, now this is going to become a negative 4 comma negative 2, and you can see that both the signs are going to be switched to its opposite. The 4 becomes its negative version, the 2 becomes its negative version too. If I were to start from over here, the negative 4 becomes a 4, and the negative 2 becomes a 2. So either way, the sign's going to flip. In other words, as far as the rule, the original x is going to become its opposite sign, and the original y is also going to become its opposite sign. So the rule is negative x comma negative y. Now, for a translation, you have to tell, just like we had to say what we're going to reflect over and stuff, we have to say how much we're going to move. So let's say we're going to move 3 up and 3 to the right and 5 up. So if I'm going to have 1, 2, 3 to, what did I say? 3 to the right and 5 up. 1, 2, 3 to the right and 1, 2, 3, 4, 5 up. Now this is going to become the point 7 comma 5 up 7, because I'm adding 3 to this and I'm adding 5 to this. Remember, if I'm going to the left, it will be a negative number. If it's going downwards, it's also going to become a negative. So if I'm moving 3 up and 3 to the right and 5 up, my rule will become move to the right 3 and move up 5. So these values, the 3 and the 5, would change depending on what the question was. Okay. So what we're learning today in lesson 4.1 is dilation. And like I said to you in the instructions, it's actually the same thing that you did with stretching and shrinking, but we're trying to learn how to write the rule for it. Okay. As far as your answer, here are your original coordinates, and since it has a scale factor of 3, you're going to multiply every single coordinate by 3. So 2 becomes a 6, 4 becomes a 12. So these are your new coordinates. This should be your answer for the new the dilated figure. So this would be p prime, Q prime, R prime, S prime. Okay, so P prime, Q prime, R prime, S prime. Okay. As far as question number 1, how do the sides of the lengths compare? Well, if you look at this portion right here, this is a length of 2. If you look at this portion right here, 1, 2, 3, 4, 5, 6. So a 2 becomes a 6. In other words, the lengths also triple. Okay. As far as how do the measures of the quadrilateral, the angles, if you look at this one, the 90 degrees is still a 90 degrees because, like we know, similar figures are different in size, but the shapes are the same. So the angles itself should all match up. Whatever this angle measurement is, it should match this angle measurement, even though I don't know exactly what the angle measurements are. So they should be the same. Okay. Question number 3. How do the perimeters compare? Well, if this is going to be 3 times as long, and this part's going to be 3 times as long, and this part's going to be 3 times as long, and this part's going to be 3 times as long, the perimeter, when I add them all together, should also be 3 times as long from each other. Let me just push autofocus. Right. Okay. As far as how do the areas of the quadrilateral compare? Well, I'm actually going to just show you how to decompose the smaller one, like I said to you. So this is something we learned back in the Looking for Pythagoras book. It was 2. I told you to break it up. In other words, since you don't know how to find the area of a trapezoid, if I break it up like this, you can find the area of this rectangle or a square and an area of the triangle and add them together. Since this is a 2 by 2, the area here is a 4, and this is 1/2 times base of 1, height of 2. So the area here should become a 1. So 4 plus 1, the area of the original figure should be 5. I'm not going to show you how to do the larger one, but if you do the larger one, it should come out to a 45. So comparing these things, the area, instead of 3 times as big, should be 9 times as big. Now, an easy way to get that is something that we learned in SAS, stretching and shrinking. It's the scale factor to the second power because it's an area. So 3 to the second power, 9 times as much. Okay. We already know about the slopes too. If you think about the slopes, the slope of this line right here and the slope of this line right here, since it's just an enlarged version, it's going to be the same. Now, keep in mind, I didn't write down the slope for every single thing, but a horizontal line has a slope of 0. So this one also has a slope of 0. And this vertical line has an undefined slope. And so does this one has an undefined slope. Okay? But regardless, whatever it is, the slope should be the same to each other. Now, finally, writing the rule. Writing the rule, I'm saying, well, what did I do to the original coordinate to make it into this dilated figure 3 times as big? What you did was you multiplied each of the x and the y by a scale factor of 3. So that becomes a 3x, comma, 3y. In other words, I'm going to add that in here. If I'm doing dilation with scale factor of 3, the x, comma, y, the x value is going to be multiplied by 3, and the y value is also going to be multiplied by 3. Now, a lot of you guys emailed me or commented on the assignment saying that you had a hard time either seeing the triangle for part B or you didn't understand part B. So let me explain this portion to you. Okay. So it says OP prime, so on and so forth. And the O is actually the origin. So let me go back to the previous page and show you. O, P, Q, so this little triangle right here, and this big triangle right here. Okay. I know it's hard to see, but if you think about it, this little triangle and this big triangle, I mean, this part and this part has the same exact slope. This part and this part has the same exact slope. So just similar to the trapezoid, they have the same slope, and whatever the length of this is going to be 3 times as long. And you could always use a right triangle from Pythagoras to figure out the exact length to compare, but we already know that it's going to be longer, the same length longer. Okay. Now, what this is actually saying, and it's kind of hard to explain, but if you look at the z is what you're multiplying for both of them. So z is your scale factor. So whatever the p coordinate point p2 comma 4 was, it's multiplying by z on both each end. Kind of like you took the original coordinate before and multiplied by 3 for both of them. Now here you're saying you're multiplying by z for both of them. So the z would be the scale factor. Okay. Again, the slopes are, these are going to match and these are going to match. I'm not going to go through every single part of part C, but your coordinates, your original coordinates, should end up looking like this. -1, 2, so on and so forth. Okay? The reason being, you are making it half as big. So instead of multiplying by 3 like part A, you're going to multiply by 1/2. So it becomes half the size. And if you look at the plotted diagram, your new diagram is actually going to end up being smaller than the original by half. Okay? Similarly, just to answer the very, very bottom, because of that, the rule would be 1/2 multiplying by the first coordinate and 1/2 multiplying by the y coordinate. Okay. So if I were to generalize what we just talked about, instead of scale factor of 3, if I have a dilation with scale factor of z, then the original coordinate x comma y would end up being, taking the x coordinate and multiplying by z, and taking the y coordinate and multiplying by z. So this is the generalization of what you're learning today. Okay. Hope you copy the summary and you understand. Today you'll be working on a Desmos activity that you can play around and actually see what happens. Okay. Have a great day.